I want to thank the PFF for the invitation. I'm really here speaking on behalf of a tremendously large group of investigators and a large group of patients, coordinators, and I just want to echo what Kevin said, which is none of this is possible without a real true team effort. So I'm here representing a large group of people. I'm here to talk about the IPF-PRO Registry, which is a collaboration funded by Boehringer Ingelheim and run through the DCRI, which involves all U.S. sites at this point in time, which also has a similar time frame as the registry that Kevin talked about. Where we are right now, you made me feel better about where we've gotten to so far, Kevin. Where we are right now is just looking at the first slice of data at baseline patient characteristics, baseline predictors, and how those things might track with longitudinal changes. But certainly, as we go along in the registry, we'll start to see how changes in variables and changes in behavior of the disease track along with things that we're interested in. So the IPF-PRO Registry is a 44-center registry entirely in the United States, as I said. The idea, of course, like many other registries, is to look at the natural history of the disease in a real-world, real data sort of sense, but then also to look at things that haven't been looked at very well in the clinical trial data that we use to inform a lot of our discussions with patients. So what is the impact over time? How do PROs change over time? How can we look at biomarkers and the change in those over time in order to understand more about the clinical behavior of the patients and perhaps biology of IPF? So here's how the registry is designed. We took a little bit different tack, and that is that we start time zero at the time that the patient is enrolled in the registry at the enrolling center. We call that the time of diagnosis of IPF. There is a backwards look that allows us to go back and extract old data on what's happened with the patient, but we really start time zero when the patient's enrolled in the registry. And what we do then is we collect data on patients in 6-month windows, again, during their usual clinical visits, and again, only on patients who are planning to come in for regular follow-up at the enrolling center. A little thing that we have in the registry that I think is very important is that we also have, besides the regular clinical follow-up at the enrolling center, we have at DCRI a call center, which for patients in whom we're not collecting data, who are perhaps potentially lost to follow-up, we can call and we can get those patients at least some data on hospitalizations, mortality, lung transplant, and features like that. And just to show you the importance of that, this is actually the subject retention in the study. And this doesn't show you very well, I'm sure it doesn't project very well on the back, but again, we start right around the beginning of 2015 here on the left side of the x-axis, and we're just looking out as we go into the enrollment of the patients on the y-axis, how long has it been since we had data collected at the site on the patient? And the line that you probably can't see here very well is the 9-month line. That's really letting us know whether the patient's been collected more recently enough within the window of their follow-up visit. But you can see a lot of patients are falling out above that, and those are patients who are potentially lost to follow-up. If you superimpose that with what the call center does, you can see that almost all of those patients drop down into those open circles and gray circles, which are patients that have data that is up to date within the last 9 months. So therefore, we don't have loss of subject follow-up or dropout of information about what's happening to the patients. And I think this is one of the real strengths of this particular registry. Here are the data that we collect at enrollment. You can see these are all fairly standard, a number of demographic data, a number of disease-specific data, data like distance to the enrolling center, hospitalization history, what's happened to the patient in terms of their interactions with healthcare system. There's a paper coming on what's happened in their pathway to diagnosis. And so we're able to capture all of those things at baseline. This is very similar to the PFF registry, I think. And then during follow-up, we collect a similar set of data, again, focusing very much on some things that haven't been explored very well in the past, like longitudinal changes in PROs, longitudinal changes in biomarkers, and healthcare economics. So those are focuses we're really trying to look at during the collection of these follow-up data. So as of September 2019, you can see that we've enrolled 1,002 patients, that about 20% of those have died, and then a percentage of them have had lung transplant, around 8%, or have had, they've dropped out of the study. And you can see that the vast bulk of them, when we use the call center, we have up-to-date data on, around 96% of them. So I'm just going to talk to you about a few analyses that we've done in the registry, just as a snapshot of the kinds of things that have happened so far and the kinds of activities that we're doing. The first one is, what about the patients in the registry? What do they look like? And this is very similar to other kinds of registries that you see. These are mostly older, white, male ex-smokers. You can see that they, many of them meet for the 2011 criteria, either definite or probable IPF. But we allowed anybody into the registry that the enrolling center felt after an MDD discussion had IPF. So we have a number of people with possible IPF, and we'll be able to tease out some of the characteristics of those over time. In terms of physiology, these again look like mostly, on average, moderately physiologically impaired patients, more in the GAP stage 1 and 2 with a CPI around 52. These are the kind of patients that I think we've seen in many of the studies that are out there. So some of the analyses we've done right out of the gate first are to look at predictors of outcome, and we just chose death or lung transplant as something that is a hard endpoint and that's easy to be confident about. And we divided the kind of predictors we were going to think about into covariates that had to do with patient characteristics, baseline characteristics, and you can see them listed there, and also into markers of disease severity. And so we looked at all of these in an unbiased way to see if it fit with what we've seen in some of the other analyses. Here's the Kaplan-Meier plot just showing the overall study. This is the first 662 patients in the registry actually, and you can see that unfortunately that the survival here for freedom from death or lung transplant is only about 30 months till you get to a 50% mark on the survival, which is a little different than some of the other registries, and I think we'll have a chance to talk about that when we get into the discussion. So what predicts this? What are the independent predictors of this? And can we learn anything new? So one of the things that I think that's very interesting that came out of this that's new is that we actually found in this registry, and this needs to be replicated, a J-shaped relationship between age after controlling for other covariates and the likelihood of death or lung transplant. So the sweet spot really was 62, and if you got older than that, or if you got younger than that, you tended to have a worse prognosis. And this is the estimate just in this plot. And so if you look at associations on a multivariable level between everything that can predict mortality or lung transplant, these are the things we found. Again, age. But interestingly, we found not only oxygen use with activity, but also oxygen use at rest to be a very strong driver of outcome. And I think for us, those of us who are in clinic, we know that there is some sort of an inflection point that often happens with patients psychologically, but also physiologically at the time when they transition into needing oxygen therapy. What about patient-reported outcomes? Do those independently predict changes in death or lung transplant for patients? Well, not as strongly. Here's a list of patient-reported outcomes, and after controlling for all the covariates that I just described and looking at the severity, you can see that except for St. George respiratory quotient, none of these are significant. They all cross the confidence interval, but there is definitely a trend in all of these that independent of physiologic variables, oxygen use, and age, that you do have worse outcomes in patients who have worse PROs. Again, suggesting we're getting novel information from those particular data points. Another thing that is in a lot of these registries and that I think is being done very well is an attempt to look at biomarkers and to do some discovery science. And so we have this thing that's called the IPF-PRO Bio, and at every single visit, the patients have serum, plasma, RNA, and at baseline they have DNA collected as well. And of course this is very challenging because that's a whole ton of data, and I'm amazed at the ability and the amount of energy it takes to get the data into a usable format. And in fact, we were talking this morning about artificial intelligence and novel ways of looking at big data sets, and I think this really symbolizes the idea that this is going to take multiple people, not only in the registry, but from other fields, other people in the room, to come together to help us answer questions that are relevant here, especially in the area of these biomarkers. So we have genomics, of course, and transcriptomics, and then also proteomics and metabolomics. And some of the data now just from baseline are coming out on those. But I think really the challenge, but also the excitement here, is the ability to overlay those things and use systems biology and artificial intelligence to start to see relationships and to start to not just focus on one or two favorite molecules or pathways, but how all these pathways across these platforms interact. And you can imagine computationally this is quite a challenge, and it will take some time. So just as an example, here's one of the initial things that's coming out. This is looking at the proteome in patients with IPF versus controls. And for this, we used just the first 300 patients in the IPF-PRO Registry, and we used a set of basically age and gender and race-matched controls from the Murdoch cohort in North Carolina. And we looked at a panel of about 1,300 proteins in an unbiased way to see which of those could distinguish IPF from controls. Now, of course, this needs to be looked at in other interstitial lung diseases, but this is the first pass through the data. If you look at this, you can find that based on just statistical significance, there's about 550 proteins. If you start looking at more important changes, like a fold change of 1.5 or 2, you can see that the numbers narrow down to smaller numbers of proteins, some of which have not been described in IPF before. And in fact, here's a volcano plot just showing exactly that you can distinguish either on upregulation or downregulation a number of proteins that distinguish IPF from controls. And here, not the same 9 proteins, but these are the proteins that in an unbiased way best give you a model with an AUC of 0.99 that allows you to distinguish IPF patients from healthy controls. Of course, this is something else that needs to be replicated, and of course there are many different investigators that have reported molecular signatures that can allow you to distinguish IPF from controls. But this is just exemplifying with the amount of patients we have and the data we have, the power to sort of do this sort of thing. And here's just a plot showing the discrimination using that 9 protein signature of the IPF patients that we have from the controls. What about disease severity? Can we also analyze that? This is another thing that's happened. This is looking at the proteome and looking at disease severity. And again, we found a number of proteins that distinguish the disease severity based on FVC, DLCO, or even the composite physiologic index, and you can see that 4 proteins were associated with all 3 of the severity markers, which allows us then to focus on those. Looking at the 3 severity markers here, you can see that there's a number of proteins, but only 4 of them overlap in between all the 3 measures of disease severity. Again, these are targets potentially for preclinical exploration. There are also potentially things that can be validated as potential biomarkers for stratifying our patients. The last thing I want to say is that now we're moving away from IPF, or we'll continue, of course, to follow the IPF, but also into this progressive fibrotic lung disease phenotype. And so the next phase of this, which is now just getting off the ground, is the recruitment of a group of patients with progressive fibrotic lung disease defined by CT or by biopsy at the enrolling center, and who meet the criteria, the same criteria that were used for the INBUILD study. And this will have the exact same setup as IPF-PRO. So the patients will be followed every 6 months. There will be biologic samples collected, PRO samples collected, information on healthcare utilization collected, and then the patients will be followed along. And of course, we'll probably learn a lot just analyzing this cohort, but also we'll learn a lot by comparing these to the IPF patients that were collected in the first part of this study. So, being involved with this for a few years, you realize that this is a tremendous amount of work. It requires a lot of attention, and also that there are a lot of registries around the world. There are many, many people looking at this from different ways, and it reminds me of the Indian proverb about the blind guys looking at the elephant and all describing it differently. And so I was really heartened to see in the last few months and Andreas, I think you're involved with this, a collaboration, a planned collaboration in Europe to start to look at how do we start to compare and work together between these registries so that we don't reduplicate our efforts, so that we can validate things that we see, and so that we can bring as many experts as possible to the table answering and asking the most important questions for our patients. So thank you very much.